Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 21 of the December daily LeetCode challenge. Yesterday we had seen a question on trees, and finally now we are having a hard question, and that too on trees. Okay, it's slightly difficult to find questions which are hard for trees. Remember that trees is generally considered to be easy topic, so it's slightly rare to find questions which are hard on trees. So today we have such question. So let us see what it is, and let me tell you the answer is going to be very short and simple. Okay, it's going to be very short and simple. Don't worry that it's a hard question. I am damn sure you after you like understand the explanation and after you understand the algorithm at least you will be able to see like how easy it is. Okay, so don't worry much, it is going to be easy. So coming to this question, it is 2872 maximum number of k divisible components. Okay, so if you see here we are basically given a tree, and let me before that you show you the constraints. So as you can see the number of nodes which are given to us, it's going to be around 3 to 10 power 4. Okay, fine, and other things I will discuss after discussing the question. So yeah, as you can see, this is going to be the tree. But see, remember one thing: compared to yesterday's question, this question how it is different. In this case, what is happening is you are not going to be given the root of the tree. Okay, so previously what used to happen, there used to be a tree node class that will be defined somewhere above your question, and then you will be just given the pointer to the root. Okay, this is not going to be like that, and that is probably the reason why it's cause, it's called hard question. We'll see that also, but there's nothing different. You have to do exactly the same thing only. So there is the undirected tree. Remember what is undirected? Undirected basically means that, so let us say there is edge between 1 and 2. So when it is a directed edge, you can only go from 1 towards 2. But when it is undirected, you can also traverse backward. That is in reverse direction. So edge between 1 and 2 basically means you can go from 1 to 2 and 2 back to 1. Okay, that is what is the undirected edge. Remember, these are just simple terms which are used generally in case of trees and graphs. So just please be familiar with these terms, because otherwise understanding the question might get difficult. But again, like, this is not related to this question. Okay, I'm just giving you guys general advice. Just be familiar with the terms which are related to trees and graphs. There is an undirected tree with n nodes, okay, which have labeled. So these are like labeled from 0 to n minus 1. Okay, so in the diagram also, and whatever you are seeing, these are basically the label values. Okay, these are just the label values. Remember, these are not the value of the node, just a label for the node. Okay, when I say the node with label 1, it is just a for representation only. Okay, but the value that we have will be different. Okay, we'll come to that. So they are represented from 0 to n minus 1. You are given an integer n. Okay, so see, this is going from 0 to n minus 1. We are also given n. So just see the input first. I guess that will be a better thing to do. See here, n is given. We are given edges. We'll come to this. This is not we have not come till this point where edges are defined. Then there is a value also given. Okay, this is going to the real value of that node. Otherwise there is see, there are two things here. There is a value for the node. There is also a label for the node. Okay, that is slightly different from what we have seen yesterday. And I'm just comparing what we have seen yesterday and what we are seeing, and why it is called hard question. Okay, you have to just interpret these things, and that is the only hard part here. Okay? The algorithm is very simple. So that is it. And yeah, you are given an integer n and a 2D integer array edges, okay, of length n minus 1. Remember why its length is n minus 1? Because it's probably a tree. Okay, that is another indication that you will have to solve it. See, they've clearly mentioned a tree here, but again, like, in order to understand what kind of tree it is, it's very much helpful for you to understand what kind of tree it will be. Okay, as simple as that. Yeah, in the diagram, based on the diagram and based on other stuffs also, you can conclude that it's almost going to be like a case of a binary tree only. Okay, otherwise you will not have n minus 1 nodes. But again, we cannot confirm that. It might see, just based on the length of the edges, we cannot confirm whether it will be strictly binary tree, or it could have more than two children. And any of the nodes could have more than two children also. Okay, so that is not something strict given to us. Okay, fine. Where edges of I is equal to AI comma BI. So what it means indicates that there is an edge between AI and BI in the tree. Okay. You are also given a zero indexed integer array values of length n, where value of I is the value associated with the ith node and an integer k. So integer k is also given to us in the input. If you see, we are also given an integer k. Okay. These are the values for each node. So based on the index we have to find. For example, for for the node with label 0, this is the value. For node with label 1, this is the value, and so on. Okay, and these are the edges. There is a undirected from 0 to 2. 0 to 2 means, again, 2 to 0 also it is possible. Okay, similar that. Similarly, there is a edge between 1 and 2, and so on. Right, fine. Now, a valid split of the tree is obtained by removing any set of edges, possibly empty, from the tree, such that the resulting components all have values that are divisible by k, where values of a connected component is the sum of the values of its nodes. Return the maximum number of components in any valid split. One thing that they have not mentioned in this question, which I feel is very wrong, is, see, this part is very important, which they have not mentioned directly in the question, but they have mentioned in the constraints. Just here the sum of values is divisible by k. Okay, so whatever input you are going to get, okay, those are the sum of the values. Okay, if you add all of this, the number is going to be divisible by 3. Okay, similarly in the other example, if you add all of these, the sum is going to be divisible by 6. Okay, in this case, so that is something very important, because otherwise without that, with this we cannot do this. Okay, similar that. So this part they should have written in the main question, but they're writing it in the constraints. Okay, which is again a tricky part. Okay, as simple as that. And now just try to understand what this part. We'll go to example one first. See, and given is 5, that means there are going to be nodes from label 0 to 4. Okay, 0 to 4, as simple as that. So the left part what you're seeing is the original tree given to us. Okay, so just one thing I want to tell you is that, see, in when we are talking about a tree, see, there is nothing called a root as such. Okay, this is something that we are defining for our convenience. Okay, so in this case they are writing 1 as the root, but you will ask me like, how should we know that 1 is going to be the root? Remember, many of at me I can say like at least 85% of it will be stuck in like telling me how to find the root, because root is not given to us directly. Normally in whatever questions we see on LeetCode, the root will given to us directly. The root will be actually the object of the tree node class, but in this question that is totally different. It's not given as such. Okay, maybe that is the reason why they have marked it as a hard question. So let me do this very frankly. See, it doesn't matter what is the root. Okay, that doesn't matter in case of a tree. Why? I will tell you. See, it just weighs your visual imagination. For example, let me talk about this 0. Try to think of this as the root. Okay, so here this edge going from 0 to 2, then from 2 there are two edges going. Okay, one is this particular one and the other will be, imagine, 4. Okay, because the way they've written you are unable to think of it, but yeah, just think of it 0 as the tree. Okay, the node. Okay, the root. Then from 1 there is towards 3. So as simple as that. See, it doesn't matter which one you are going to take you as your, the root. Okay, doesn't matter. They've given here one. You need not do that from, actually in my solution I am not doing from this particular one. Okay, I'm not taking this as the root node. Okay, I will always take the node marked with 0 as the root node. Okay, in my solution. So it doesn't matter. See, in case of tree it doesn't matter. Okay, as simple as that. You can take anything as your root and you can start from it. Okay, as simple as that. Yep, that is what I want to say, right? Because see, all of them are going to have, at most, some children's only, as simple as that. And obviously when it's a tree, there is no chance for it to be a cyclic edges present. So for that reason you can start from anything. Okay, as simple as that. Fine. Now see here, they have given this. Remember, the numbers which you're seeing are not the values are given here. Okay, now they are saying that if you take 1 and 3 separately, okay, what is 1 and 3? One, they say 1 and 3, this is going to be this particular one and this particular 3. Okay, as simple as that. So 8 plus 4 is going to be 12. So 12 is going to be divided by 6. So that's what they are claiming, that this could be a separate component. Okay, so this is a separate component. That is, if you add this and this, you are going to get a number which is 12, which is divided by 6. Okay, so it's a separate component. The rest of the three values which are going to be 1, 1, okay, and 4. So 1, 1, 4 is actually 6. So 6 is again divided by 6. So this particular component that you're seeing, 2, 4, and 0, that is again having a sum which is divided by 6. Okay, so for that reason they are trying to split it like this. Okay, similar to that. So the no root, that is the, you can say like the edge between 2 and 1 is getting broken. Okay, as simple as that. So yep, you have written 2 is the answer, because there are two components getting formed. And remember, see the question again, written the maximum number of components in any valid split. Okay, now coming to the other example, if you see here, example number 2, again the same thing. See, I'm not doing the again the whole sum calculation here. You can do that on your own. But see here what is happening, they are just dividing this part. Okay, the edge between 0 and 2 and the 0 and 1 is getting broken. So now we can start the solution now. Before that, yep, there is nothing much to show you, but the only thing that I want to tell you is that, see, try to understand this fact. If we are at the edge node, okay, if a particular node doesn't have any children, in that case what we have to do, in that case, if the leaf node has a value which is directly divisible by k, in that case the leaf itself will be a separate component. Okay, as simple as that. And then we will, if that is not possible, we will try to merge that particular leaf with its parent. Okay, in this case let us say 5. 5 in just assume 5 in itself is a, having a value which is divisible by k. So 5 will be treated as a separate component here. Okay, you can just add 1 to your answer in that case. If the value 5 is not going to be divisible by the k, then we'll have to merge this value with its parent. That is, you'll have to return its value such that in some iteration this particular 5, the value gets added to the value of the parent node here, which, okay, as simple as that. Remember, 5 is the label. 5 will have a different value, remember that. But just I am telling you for example purpose. Okay, whatever is the value for this node, if it is divisible by k, treat it as a separate component. Okay, as simple as that. In the rest of the sum, you should not include the sum of this particular leaf node. Okay, as simple as that. So I will, my solution will also do the same. We will do a DFS approach. We'll go till the leaf node. If the leaf node has a value which is divisible by k, we will calculate as a separate component. We will reduce its value to 0. Okay, as simple as that, because it's already taken. So in the rest of the calculation, we will not do that. Okay, let us say a particular leaf node is not having a value which is divisible by k, so we will add its value to its parent node's value. Okay, in that case, that is for the whole subtree including its parent. We will try to see if that itself could form a component. Okay, in this case, if you see the subtree starting from 2, okay, there is all the children of 2 and so on is forming a subtree which is treated as a component because the sum of it is having a value and sum of it is having the value which is divisible by k. Okay, and so on. So if you see my solution, I will show you both Java and Python solutions. So just see here what I'm doing. First of all, I'm declaring the answer to be 0. Okay. Remember, in this case, one thing is very clear. If you see this constraint, that's why I showed you in the starting itself. If you see this part, one thing is very clear. The minimum answer that we can have is 1. Okay. In the worst case, we are going to have the answer as 1. Okay. In the minimum answer. Okay. Now, that is the reason why I've done this. Max of answer comma 1. Okay. Which is the max one that you have written. Fine. Now come to the other part. Now, I am defining a default dictionary. Okay. For the value is going to be of the type list. What is the default dictionary about list and all? So see, the idea is very clear. For each key, the value is going to be a list. Okay, simple as that. That's what is the default dictionary. It's a special kind of data structure I'm importing from collections. Okay, you can also use the normal mapping data structure in Python. That also will work. The only advantage this gives is that see, we don't have to initialize a particular thing. Okay, by default, whenever you put a key in it, by default the value is going to be empty list. Okay, for that, this is the only advantage. Other than that, there is no advantage. Okay, fine. I'm defining this as the tree. Now I'm going to populate my tree and then I'm going to print it. I will show the print dot before starting the solution. Okay. So what I'm doing, I'm going through every I comma j. Okay, in the tree. Remember one thing, they've clearly mentioned it is going to be a undirected tree. Okay. So for that reason, what I have to do, I have to do tree of I dot append j, and similarly the reverse tree of j dot append I. Okay. I'm doing both of them as simple as that. Okay. So from the parent towards the root also there will be from the parent towards the child also there will be edge. From the child towards parent also there will be edge. Okay. Because it's an undirected edge. Okay. Remember that. Then I'm printing this tree. So first let me show you the output of this particular stuff. So this is how it is going to look like. Okay. Okay, let me just zoom in and show you. Yep. Okay, as you can see, like, see, this is the root. Okay, this is the key. For it, the value is going to be 2. That means there is a node from 0 towards 2, and similarly when you go to 2, there the value of them is also having 0. Okay, so see, this is the whole value that is from 2. There are edges to these of the nodes. Okay, 0, 1 and 4. Okay, from 0 you have edge towards 2, from 2 you have edge towards 0 and so on. Okay, so 2 is having edge towards 0 and 1 and 4. You can verify that. Okay, 2 is having edge towards 0, 1 and 4. Okay, now 1 is having edge towards 2 and 3. Okay, as you can verify from here, one is having it from 2 and 3 and so on. Okay, and same is for other cases. Okay, just you go that and verify it. Okay, there's nothing much for me to explain you. Now I am defining a DFS function. This is going to be the prime thing. Remember, this is the only, just you can see there are just 7-8 lines, something like that, and this is done. Okay, with this I'm able to get this whole solution. I'm just calling this function and I'm getting the solution. So all trick lies in this. Just try to understand what is happening. Okay, let me zoom in and let me begin now. Yep. Yep. So this is the device function. See, first of all, I'm declaring the non-local answer. What is non-local answer? If you haven't following my video, I'm damn sure you will be doing this. So basically, whenever you're declaring a function inside a function, if you want to access any parameter which is declared outside this function, which for example the answer, you should write non-local. Okay. Sometimes it is not needed. That is depends on the compiler. Sometimes the compiler does it by itself, but in some cases it is good to write it. Okay, as simple as that. Next, I'm declaring a variable called sum of subtrees, initializing it with 0. Then what I'm going to do, I am going to all the that is all the edges, that is all the nodes from which the current node has edge. Okay, for the current node, see, what is the passing value? See, I will have the node and I will have its parent. Okay, simple like that. Now what I'm going to do, for this node, to which other nodes, that is all the adjacent nodes of this node. Okay, for example, if you see here, yeah, for example, the number 2, if I'm at the number 2, so these are the nodes to which I have edge. Okay, these are going to be my adjacent nodes. Okay, so same thing I'm going to iterate to them. Okay, for I int tree of node. Okay, I will going through all the adjacent nodes of the current node. That is, see, I don't want to go back to the parent. Remember, from the parent I have come to this node. Okay, so I don't want to go back to the parent, so I should not be equal to parent. Okay, as simple as that. If that is the case, what I have to, for all the rest of the nodes, what I have to do, I have to call the device function again. Remember, it's a recursive call. Within the function, I'm calling the function again with a different value. Okay, so what I'm passing the I. What is I? I is going to add node for the current node, and the current node is going to be its parent. Okay, as simple as that. Remember, we are not going back to the parent. Okay, so I and the current node. Okay, the next node and the current node. Okay, as simple as that. This particular node will act as a parent to that node. Okay, that's simple as that. And then whatever value is being written, I am adding it to some of the subtree. Okay, simple as that. Next, once I'm done with this, what I'm coming and doing, I'm just checking whether some of the subtree, okay, that is value of all of this child nodes plus value of the current node. Okay, I'm adding them. Okay, these two I'm adding, and then I'm checking whether the percentage k is equal to 0. If that is the case, I'm doing answer plus 1. That is, I found a new component. Once I have found a new component, that should be separated from the graph. That is, when we are returning, see, for example, I found a component. For example, in this case, if you see this 2, 4, and 0, the label node with labels 2, 4, and 0 is now a component. So the value of these nodes should not be added to its parent node, and that is all. Okay, that's what I want to say. This is now a separate component. The value of this should not be passed back to its parent. Okay, so for that reason, I'm going to return 0 now. Okay, as simple as that. So now how it will work, now in terms of leaf node, just think of what will happen. See, if let us say this particular node is now a leaf node, so what will happen, now you will go through all of its the adjacent nodes. For example, for a leaf node there are not going to be any adjacent nodes. Okay, the one which will be its parent, we will not go to that. Okay, so the sum of subtree will be empty in that case, as simple as that. So what will happen, so when we are doing this calculation, basically this will always be empty for a leaf node, only this will be some value will be there. Okay, let us say this value is going to be divisible by k. In that case, I will return 0. That is, now that node is going to be treated as a separate component. Okay, that is the reason what I'm trying to say. Okay, if let us say it's not going to be divisible by k, so what will happen, it will return. Okay, it will return this value. Okay, that is, this will be 0 only, so the current node's value will be returned. Okay, it will be returned to its parent node. Okay, so when the parent node is receiving that value, it will be adding it to its sum of subtree. Okay, and then from there on it will be calculating. I hope you're now understanding. See, whenever we are able to find a component, whenever we are able to find a node or a subtree whose sum is divisible by k, we are returning 0. That is, we are not trying to detach it from the rest of the nodes. Okay, as simple as that. From the rest of the tree, we're trying to detach it, and we're incrementing one to the answer. Okay, as simple as that. So when we're returning 0, that means when the parent node is calling this, so here the 0 will be passed. Okay, here the 0, this particular function will pass 0 in that case. Okay, because we're returning 0, this will be 0, and 0 will be added to that. Okay, so it will not be contributing to the sum of its parent. Okay, parents, when in the parent, when we are calling this sum of subtree, that will not be contributed for a node whose this particular condition is true. Okay, as simple as that. So, and this is the first call to this recursive function. What we are doing, we are starting from 0, and as a parent node I'm passing -1. Remember, -1 is not a parent of 0, but just to differentiate, I'm passing it as -1. Okay, okay, as simple as that. Maybe like you can just write it is equal to -1. You can also do that, and you can remove this part. Maybe you can think of that, think of it like that. But yeah, again, it depends on you. I am not doing that. You can do that also. Fine. So I hope you understood this question. What is happening? From, see, idea here is whenever we are able to justify this, we are going to pass return 0. If you're not able to do this, what you have to do, you'll have to return the sum of the subtree and the current node. Okay, so it will be sent back to its parent. That is, it will try to be merging the node to its parent node, and so on. And then we are trying to form a component. Okay, so yep, that was the solution. I've already submitted this and it got accepted. Okay, this, as you can see, I've already submitted this also. If you talk about space and time complexity, so see here, we are just going through the edges and we are calculating them. We are storing it in the data structure. Okay, so the space component is going to be of e. Remember, I'm not considering the stack, the space that will consume by the stack. Okay, that will be dependent on the depth of the tree. Okay, again, I'm not considering that in this case. Okay, and now if you talk about the time complexity, so see, this is DFS. What it will do is, it will go through each node and each edge. Okay, so it will go through and it will return back also, so 2 times. So for that reason, it's going to be O of n plus e. Okay, simple as that. Now coming to the Java solution, see, just see one thing here. Just I want to show you one thing. See the how the Python solution is looking so simple and so much efficient, and it's so small to write and so small to see and understand. But let me show you the Java solution for the same logic. Okay, exactly same logic. This much is the Java solution. It's slightly bigger. Okay, so let us go through this also. First of all, I am importing the util library because I will be using this much. I will be using map, I will be using hash map, and I will also be using list. Okay, I am also using okay, array list and list. Okay, as simple as that. List. So for that reason, I'm doing doing the java.util dot start. Okay, I'm doing a start because I want everything. I cannot write separately for a hash map or a list or a map separately, so I'm just starting start. Next, I'm importing java.lang.math. Why? Because I need it for doing the max function. Okay, remember, max function is basically a static function, so it should be used only with the name of the library. Okay, you cannot simply write max. Okay, so what some people think is they can write java.lang.math dot star, and they will simply write max here without the math dot. Okay, so that is not possible. Max is actually static function. It has to be written with its the parent the file name. Okay, which is math, as simple as that, which the basic basic, sorry, not basic, the parent class name. Okay, as simple as that. Next, what I'm doing, see, these are going to be the data members of the class. Okay, this is the class solution. These are going to be its data members. So what are the data members? First of all, the tree. Remember, the solution exactly same as that of the Python solution. Exactly, name is also matching with that. Okay, just a second. Exact same names. Okay, I am expecting you to first go through the the Python solution and then come back to Java, because Java solution is slightly lengthier. Okay, remember, approach remains the same. Even the names are kept same so that you can go through it and understand clearly. Okay, So yep, this is the map. Okay, what it will do, see, the key will be integer, the value will be a list of integers. Okay, and this is the hash map, as simple as that. I'm declaring an answer as the data member of the class. I'm also declaring a node values, and also I'm declaring an integer k. Okay, fine. So remember, this node value is just nothing different, it's just the values. Okay, just because I have to make this as a, I have to access these values in the other functions also of the class. For that reason, I am declaring it as a global variable. Okay, within the class I'm declaring as a variable. Okay, data member of the class. Fine. This is the first function, and this is the original function, okay, that we are given by LeetCode. Okay, fine. This is the original function. Now what I'm doing here, exactly same thing. First of all, this dot answer equal to 0, this dot k is equal to k. What is this? See, this dot k means this particular k. Okay, the k which is a data member. Okay, and what is the other k? This k is coming from here. Okay, from here. Okay, as simple as that. Now this dot nodes value is equal to values, again same site. Okay, next what I'm doing, I'm see, this is for inserting, that is for capturing the edges of the nodes. Okay, as simple as that. Remember how big it looks, but in Python it was so easy to write it. Okay, so what I'm doing, I'm going through each of the edges. Okay, see, if you see edges, it is going to be like this. Okay, this is going to be this is going to be array in itself. So I am trying to capture it using a for each loop. Okay, using I. Okay, so what I'm trying to check, if I of 0 is not in, that is the key I of 0 is not in the tree, what I have to do, I have to first insert it. Okay, so tree dot put I of 0 comma a new array list. Okay, a new array list. Then what I'm doing, I'm just doing tree dot get I of 0, that is I'm trying to get this particular array list, and then I'm adding to it the I of 1. Okay, as simple as that. Fine. Next, what I'm doing, same thing. Like if you see the Java Python solution, I am doing the exact same thing. Okay. First, we'll have to tree dot I dot append j, similar tree dot j dot append I. The same thing we are doing in Java, but in Java, see, there is no data structure called this. Okay. There is no default dictionary structure for that. For that reason, we'll have to do everything on our own. Okay. For we have to do everything on our own. Okay, so yep, coming to that part, again same thing. If this key is not present already, what you have to do, you have to first add that key. Okay, so I have 1, this is the key. For it, I'm adding a value of this. Okay, this is the value for this. Okay, this is a list. So in that list, once I have the list, now what I have to do, I just get I of 1, that is this particular list will be written. In that list, I am doing dot add of I of 0. Okay, so that is from, I'm adding both the edges. From I of 0 to I of 1, I'm adding edge. From I of 1 to I of 0, I'm adding another edge. Okay, simple as that. Now once this is done, I'm just checking whether the key 0 is there in my tree or not. Okay, if it is there in my 0, if it is there in my if it's there in my tree, I'm just calling dface of 0 comma minus 1, just like we did in Python. In Python, I did not check this part because I was using a default dictionary. Remember that. So I was using a default dictionary, so I did not check this part. I can simply call it, because even if it is not there, it will show empty list for it. But in Java, this is required. Okay, as simple as that. And again, when we're returning, we are doing a math dot return of answer comma 1. Okay, because remember, you're starting answer with 0. Okay, if there are no edges, let us say, in that case, we'll have to see, this also will not be true in that case, so we have to return 1 in that case. Okay, as simple as that. Because why, I am sure we will be knowing this, sum of values is always going to result by k. For that reason, answer is always going to be 1. Okay, so that is the whole tree as it is will be a component in itself. Okay, the whole tree will be a single component. Now, so here I'm calling the deface function. Let us go to the deface function and see what is happening. See here, I'm just remember one thing, this is very important now. See here, it is going to be long. Why? We are going to add the sum of all the values. Okay, if you see what is a single value going to be, yeah, a single value has around 10 power 9. Okay, so for that reason, I've kept the data type as long. Okay, long sum of subtree is equal to 0. And then I am going through each of the adjacent nodes of the current node. Okay, see, this is the current node, this is parent node. Okay, for the current node, I am going through all of its adjacent nodes. Okay, how I'm doing that? I'm writing a for each loop. Okay, I is going to represent each of the adjacent nodes for the current node, and I'm going to get that tree dot get of node. Okay, tree dot get of the current node. Okay, as simple as that. So what I'm doing next, if I is not equal to parent, that is, I don't want to go back to the parent, because from parent only I came here. So if I is not equal to parent, I'm calling this function again. So it's a recursive call. I am passing I as the node, next node, and I'm passing the current node as the parent node for the next node. Okay, and so on. So it will return some value. That value I'm going to add it to my sum of subtree. Okay, as simple as that. So once this part is done, what I'm trying to do, see, the same thing which I showed in Python. This the value returned by my subtrees, that is subtree of the current nodes, and the current nodes value. Okay, and the current nodes value, if the sum of these two, okay, if the sum of these two percentage k is equal to 0, in that case I'm doing answer plus equal to 1. Okay, as similar as that, and I'm returning 0. That is, once I have found a component, I will increment my answer and I will return 0, because see, I don't want the value of this component to be passed on to its parent. For that reason, I will return 0, so that from the parent side, when this is called, okay, so 0 will be written for that component. Okay, as simple as that. if this is not true, if this particular condition is not true, that is, if the current component, if the current node and its subtree is not having a value which is divisible by k, in that case we'll have to try to merge it to its parent. Okay, so what we'll do, we'll pass sum of subtree plus node of values of node. Okay, the current node's value, as simple as that. Okay, now let us think of the case of a leaf node. Okay, in leaf node what will happen, same thing. See, in leaf node what will happen is, for the leaf node, okay, only the it will have only a edge to its parent. Okay, so this condition will be not true. So in the idea here is, for leaf node this will be always zero. Okay, this will be always zero, so this will be zero. So we are only going to test whether the node's value is divisible by k or not. Okay, if the node's value is divisible by k, it will be a separate component. If that is not true, we will return the node's value. Okay, this we are returning node's value, and this will be zero in that case. Okay, so yeah, and that was the solution, and I've already submitted this. As you can see, this is clearing the test cases, and I've already submitted this. So the only difference I'm trying to show you, that, see, that is why the reason, see, Java also you can use, but see how much length it is. Just to the same thing what Python could do, I use this much typing I have to do. Okay, so that is why, like, for beginners it's always better to start with a programming language like Python, where you can get everything ready made. Okay, you have to just think about the logic of the algorithm, and you don't have to worry much about the data structure. Once you're having the algorithm, maybe you can come and do it in Java, because Java has slightly faster speed of execution. But remember, the disadvantage in Java is that the JVM, that is the loading of the Java, for example, all these libraries and so on, for the basic compilation of a simple program, the space that it will consume is very much high. Okay, so you can do that. You can segment the solution, try to see the space that it took, and just compare the space that the Python solution took, what I showed you. You will see a huge difference in that. Though the Java solution is faster, but the space that is going to take is slightly longer, slightly bigger. Okay, as simple as that. So yeah, and that was all for this particular video. I know this is slightly longer, but yeah, I hope you now understand this thing very clearly. Since this is a marked as hard question, I wanted to remove your fear. That's why I created a detailed video on this. But remember, first follow the Java solution if you are a beginner. Only then go to the first follow the Python solution. Only then go to the Java solution. Unless and until you are perfect in Java, do not try to jump to the Java solution initially. You will not understand anything. Okay, so just go through the Java Python solution once and then go to the Java solution. That is my advice to you. So yeah, and that was all for this particular video. If you like my words, please do subscribe to my channel. This really gives a lot of motivation to continue further. I'm really tired now, so I'm not making any Hindi video for this particular solution. But yeah, if you really need it, please do comment below this video. I will make and upload. I will upload it, because the first video itself is so much longer. So I am thinking not to make a Hindi video for this. But if you need it, please do comment. I will surely make the Hindi video and upload it. Okay. So yeah, and that was all for today. Please subscribe to the channel. See you tomorrow.